So here we have x to the power of minus 1 is 1 over x. I'll just give you some example of how that would work if we had x divided by x squared. Well, that's x to the power 1, just x. And if we subtracted, we'd have x to the power minus 1. If we divide it down, we divide by x on the top, giving us 1, divide by x on the bottom, giving us that. So there's a proof of that formula. Similarly, x to the power minus 2 is 1 over x squared. We could look at this as being x squared to the power of minus 1. So this power means 1 over whatever's inside the brackets. And similarly, here this is x cubed to the power of minus 1, so it's 1 over x cubed. Here, anything to the power 0 is 1. Let's have a look at how that works. So we've got x to the power of 5 divided by x to the power of 5. Well, if we subtract the exponents, we have 5 minus 5, which is 0. And of course, anything divided by itself, apart from 0, is 1. So x to the power of 0 is 1. X to the power of a half is the square root of x. So we know that square root of x squared is 1. Excuse me, is x. Apologise. Is x or x to the power of 1. So if we said x to the power of a squared is 1, is x to the power of 1. So this is x to the power of 2a is 1, because we know we can times those two, multiply those two exponents. Done it again. So therefore we can say 2a is 1, so a is a half. And similarly, if we're saying the cube root of x cubed, we know is x or x to the power of 1. So if we don't know what the power of the cubed is, x to the power of 1, x to the power of 3a equals 1. Sorry, lift that up a little bit. So 3a equals 1, so a equals a third. So here we could look at this as x to the power of negative a half is x to the power of a half to the power of negative 1. So this is 1 over x to the power of a half, which is 1 over root x. This is x to the power of negative a third, so doing the same thing, x to the power of a third to the power of negative 1. So it's x to the power of negative, so 1 over x to the power of a third. So it's 1 over the cube root of x.